Kia ora everyone, thank you for tuning into our lunchtime webinar today with the Timber Design Society. We'll just give it another minute for more attendees to hop on and then we'll get started. Just for those who have just hopped on, we're just waiting for a few more attendees to come through and then we'll hand it over to our host for the session. But to kick us off, just a little bit of housekeeping. So on the bottom of your screen, there's a Q&A button. You can submit your questions on here at any time during the presentation, but we'll collate them to the very end to spark a conversation with our speaker. Questions are also open for all attendees to view, so we do encourage you to use that upvote function on any questions that you might be curious about too. And this webinar is also being recorded today and will be available on the TDS website in the very near future. With that, we're at 12:01, so I'm going to hand over to Emma to get us started today.
Thank you, Caitlin. Hi, everybody. Thank you for joining us today. My name is Emma O'Neill. I'm a structural engineer at PTL Structure and Fire, and I'm also on the TDS committee. So before we get into today's webinar, I'm just going to go over a bit of housekeeping and a few upcoming events with TDS. So the next seminar that we'll have is on July 18th, and that's going to be with Shailing Pei from the Colorado School of Mines. And he's talking about Tall Wood Project, findings from the world's tallest full-scale shake table test. We've been very lucky to have Shailing here in Christchurch for the last month and a half, and he's given a few presentations in Christchurch. So if some of you have been lucky enough to see those, that's great. But if you're somewhere else around the country and haven't had a chance, that will definitely be a very interesting presentation to watch. Coming up on the 4th of July, there's also an Engineering New Zealand webinar, which is going to be given by Daniel Moroder from TDS. And he's going to talk about lessons learned in mass timber construction and talk about a few of the kind of big failures in timber projects that we've seen around the world and some lessons that could be learned from that. Coming up in August, we're going to have another webinar about understanding carbon emissions of structural timber products with Phoebe Moses from Becca. And we're also going to have a bonus extra webinar in August with Adam Jones from CLT Toolbox. And he's going to present about the new CLT Toolbox modules about large diameter dowel connections to NZS AS 1720.1, which is going to be launching this month, which is very exciting. So look out for that. As always, if any of you have any topics that you're really interested to learn about, or if you have an idea of something that you'd be happy to present, please get in touch. We're always happy for feedback about these webinars. Also coming up is the CSOC and TDS seminar series on timber design, and that's going to be traveling around the country and stopping in various cities from July 22nd to 31st. There's still plenty of spots available, so please sign up if you're interested. And they're going to be going over durability and moisture management, as well as realizing design impacts on build costs for timber buildings. So as always, we'd like to give a big thank you to our sponsors, Future Build, MyTech, Simpson Strong Tie, XLAM, iBuilt, and Rothoblast. We wouldn't be able to do these webinars without them. And moving on to today's webinar. So we are going to be hearing about cross-laminated timber manufacturing and quality assurance from Thomas Lim. Thomas is a senior lecturer at the School of Forestry at the University of Canterbury. He has expertise in wood mechanics, engineered wood product manufacturing, and structural performance evaluation of timber building components. Before coming to New Zealand, Thomas was an assistant professor at Mississippi State University, where he led numerous research projects. Currently, he's leading research projects on innovative engineered wood product development and structural evaluation of timber buildings affected by natural hazards. Today's webinar is going to be, as you can see up here, about cross-laminated timber. CLT is a structural two-way spanning product that has significantly contributed to the realization of mass timber construction worldwide. A well-established CLT manufacturing process ensures the manufacturer's productivity and product quality. This webinar is going to provide an overview of the CLT manufacturing process and comprehensive information about product qualification requirements. So thanks very much. I'll pass it over to you, Thomas.
Thanks, Emma, for the introduction. And it is my pleasure to give a webinar as a TDS committee member. So as Emma said, today's topic is about the manufacturing process of CLT. and the qualification of the product, and also the quality assurance. So here's the outline. I'm gonna have a brief introduction about what CLT is. I think probably most of the attendees know about it. And the CLT product standards, what are the ones out there, and the manufacturing process, and the product standard, which the one that I'm gonna cover today is international standard, ISO 16696. And it actually has several sections in it, but I want to focus on three sections, which is going to be component requirements, performance criteria, and quality assurance. So CLT, this is the definition that came from APA, the Engineer to Wood Association in United States. It is a large panel, right? It is a large panel. It's prefabricated. It actually has, but this this definition here, which says consists of several layers of kiln-dried lumber boards stacked in alternating direction, bonded with structural adhesives, and compressed to form a solid straight rectangular panel. I think that's a bit outdated. I'm sure that this definition will be probably updated by APA sooner or later, because today you're going to see that ISO allows to use non-lumber product. So it's going to be like plywood or wood-based materials pretty much. I mean, wood-based panel materials pretty much. And so what are the CLT standards that's out there? Well, ISO 16696 is something that some of you guys are familiar with, and ANSI APA PRG320, that's valid for United States and Canada, but they all say that it's a North American standard. And EN 16351, that's a European standard. And also, even for smaller markets, such as Japan and South Korea, they have their own CLT product standard, JAS 3079 and KSF 2081. What do we have in New Zealand? We are not covered specifically by any specific product standard yet. And what about Australia? I believe they are not covered neither, but they are. So they're using, the manufacturers are using ISO 16696 as the overarching product standard, and they're using in combination with other standards as well. So these are not the complete list, but these are the ones that's being somewhat used the most. And ISO, NC, and EN are the ones adopted mostly around the world. And you will see why. Like, let's say, oh, how come we are our facility, our manufacturing plant is qualified on the ISO 16696? Doesn't that mean that it's a complete our production or our CLT is qualified to be sold in any market? Well, you'll see it's not going to be the case, because it's pretty holistic and very general, but it's not really specific. Okay. So let's start with the CLT manufacturing process. CLT, this is actually from the CLT handbook. This was actually first written by FP Innovation in Canada, and they also published a US edition. So you'll see that the given condition is lumber, not timber, because in New Zealand we talk about timber, not lumber, right? And it was also made when the CLT first entered North American market. So you're gonna see that they're only discussing how to use dimensional timber, not wood-based panels. Okay. So let's look at the first three process. And one process that's missing is a finger jointing here, which I'm gonna talk in a bit. And so you can start with the primary lumber selection. It goes, you have to create the timber and say you give the you confirm, even though you're buying the timber from the sawmill at the grade, you actually create them again. And then when you buy the timber from sawmill, they are mostly 19%, at least in North America. And you see that when they say kiln dried, it's the average moisture content they're referring to is 90%. So, but for CLT manufacturing, the recommended MC moisture content is 12% plus minus 3%. Which means it has to be somewhat redried or conditioned to a lower moisture content when it gets to the CLT manufacturing plant before it gets made up. And so once the lumber gets are graded, it's trimmed and the defects are removed. What that means is it goes through the finger jointing. So most of the CLT panels are like large in terms of length. They are going by like at least 12, I'll say like 12 meters to 60 meters easy width length. So finger jointing is somewhat like, it's somewhat compulsory. Once it's finger jointed, and then the lumber grouping happens again. So what does it mean by lumber grouping? It's preparation of the lumber for major and the minor strength direction of the CLT. And then and then the lumber gets planed the lumber gets planed on 4 sides. So why do you have to do that? You have to refresh the wood surface to reduce oxidation for better bonding. Okay, and what's recommended, the removal of 2.5 millimeters from the thickness and 3.8 millimeters from the width are recommended. And so these are the finger jointed timber that's getting planed, and once that's done, they get cut to the length, and they go for this adhesive application. Depends on the species. They sometimes put primer too. So, for example, in South United States, they use southern pine as a major species. And for that species, if they're using certain glue, they have to go for the primer, which enhances the gluing of the adhesion between the board and the adhesive system. So the adhesive types, like these are the common ones: polyurethane, melamine, and the phenolic-based adhesives, and feed speed. And also adhesive applicators and the spray rate, those ones are recommended by the manufacturers or the adhesive suppliers. And edge gluing is optional. Many producers are going for the edge gluing nowadays, but it is additional cost, and based on the research, it actually has the trade-off between the cost and the improved product performance is somewhat making the manufacturers to invest less on this edge gluing. So it's optional. And one thing that the manufacturers have to keep in mind is the manufacturing condition. So the curing of the adhesive, the curing rate is going to be different during winter and summer. Depends on the temperature of the atmosphere, temperature in the factory, and also the relative humidity. So that needs to be taken into account when they are deciding like how long they're going to press their boards, the panels for. So now they're ready. The laminations are ready to be laid up. So like for today's presentation, I'm gonna go switch back and forth between the timber and the lamination. So lamination is piece of timber that goes into CLT. So lay up, adjacent layers are laid up perpendicular to each other. You need to consider the assembly time here. Assembly time is the time interval between the spread of the adhesive on the layers and the application of the target pressure to the assembly. But most of the large-scale manufacturers, I mean, I would say all of the large-scale manufacturers have automated system for this, so they can time lay up consistently and accurately. Now pressing. you need to press to consolidate the laminations into the panel, and these are the two main press types. One is this vacuum press that you see on the right, and the ones that you on the left is the this hydraulic press or the mechanical press. So what are the advantage of each? Mechanical press actually has much higher capacity for the clamping pressure. And on the right that you see with this vacuum press, it is theoretically clamping pressure is going to be about 0.1 MPa, but if it's combined with some other clamping system, then it can be higher. But for the hydraulic press, the clamping pressure capacity can be as high as 1.5 MPa. Advantage about this the vacuum press, it's very flexible system. So if you if the manufacturer is considering to make this curved CLT or some with some curvature, then this will be a good choice. And another thing that you have to keep in mind is going to be the cost. Cost of this hydraulic press is going to be much more expensive than compared to this vacuum press. Once they're pressed, they go through the last two stages, which is machining, cutting, and packaging, which I'm going to talk in a bit. So CNC is needed for cutting the openings and the profiles for the windows and connections and so on. And nowadays, they implement this sander to control the target thickness very tightly. And also QC happens, QC happens here before it gets packaged up, which I will discuss more later. Packaging and packaging and shipping. Because CLT panels are intended for use under dry service conditions, the panels should be protected from the weather during the transportation, storage, and construction on the job site. So that's pretty much covers the overview of the CLT manufacturing process. Also, I'm now going to move on to CLT product standard. Bear with me, I'm very familiar with PRG320 since I actually worked in the United States, but this ISO 16696, I know that Australia, this the standard committee is reviewing to somewhat adopt this ISO 16696 as the national standard. So I decided to actually give a talk about this one. So the aim of the presentation from now on is to introduce what's included in the standard, so you have brief understanding of how the performance of the CLT is being guaranteed under this standard. So this ISO 16696 is based on EN, European CLT standard, and North American CLT standard. So EN 16351 and PRG320. Okay. And it applies to the CLT consists of at least 3 layers of solid sawn timber or wood-based panels adjoined orthogonal to each other. So now it talks about wood-based panels. Okay. So they're trying to be flexible with the raw materials, and this is the scope. Okay, so CLT qualified in according with this standard are intended to resist effects of moisture and moisture on structural performance as it can occur due to construction delays or other conditions of similar severity. And where is that coming from? That's actually coming from this ANSI APA PRG320. So it actually says the same. It has the same statement, but what's missing is in PRG320. It says clearly, say CLT panels shall be used in dry service condition. So it's not actually talking about use for the outdoor condition. So we're going to review this the component requirements. So solid, it's asking, it's allowing this two materials, a solid sawn timber and wood-based panel. So you see that for the sawn timber, I get questioned many times about which species can we use. Well, under this standard, it says any species recognized by national standard is okay as long as the published characteristic density is greater than 300 kg over cubic meter. And the thickness requirement for this timber is going to be, it has to be greater than 6 millimeters and less than 50 millimeters, which is very general compared to PRG320, which is asking for 15 millimeters as the minimum thickness. And for the width requirement, it has different width requirement for the major direction and the minor direction. So for the major direction, it's looking at 1.75 times the thickness, and for the minor direction, it's looking at 3.5 times the thickness of the lamination. And for the wood-based panels, it says it refers to the national standard for the product, national standard of the wood-based panel, as also they're asking for this national standard for formaldehyde emission as well for the wood-based panels, since they're mostly made with structural adhesives. Moisture content is for the timber, it's asking for plus minus 4% of the reference MC, which is going to be around 12% for most of the softwood. And for the wood-based panels, it's looking at 8 plus minus 4% for the other, unless it's being specified in the governing national standard. Phase bonding, they're asking it to be planed for the timber, but not for the wood-based panel. And it should be for the timber, it should be free of raised grain, torn grain, skip, burns, and so on. And for both of the materials, there should be no dust or foreign manners or exudation. There's also this phase bonding dimensional tolerance as well. And let's look at what they're asking for the adhesive. Adhesive requirements can be divided into two parts, basic and additional. So any adhesive used for CLT should meet basic requirements for the intended service class, 1, 2, 3, as shown. But where local building regulations require heat durability testing, then additional requirements should met. Which means this creep resistance and shear test at elevated temperatures are needed. So for the basic requirements, you just have to do the shear test, delamination test, and the creep resistance test. But for the well, if there's a heat involved in it, then you have to do the test at the elevated temperatures. Finger joints, it refers to the ISO 10983. And this is something interesting about ISO standard, glue line integrity for glue line between the layers, face joints. Well, these terms are actually copy and paste from the standard, so these are not the stuff that I made up, which sounds a little bit weird to me. But it refers to the national standard delamination test. So most of the countries have glue-lam standard, and most of the CLT, this delamination test procedure is based on glue-laminated timber, this delamination test. So it wouldn't be too difficult to find the national standard delamination test around the world. Allowed delamination rate is 40% of the total single glue line length and 10% of the total of the sum of the all glue lines. So large finger joints. So one interesting. They're trying to be. I would say in here they're trying to be comprehensive. and referring to actually European code, European standard. So it allows this large finger joints of panels. So it's the joint between the panels, not the laminations. It's as I said, it's following the recommendation of European standard, and it states the bonding strength is expressed as the characteristic bending strength of the large finger joints. So how are they being tested? They're tested in this 2-point loading from the top. And it looks quite similar to probably many of you guys are familiar with this bending test setup. It's very familiar with this is very similar to the full span bending test setup from the European standard, but the only difference is the load span. You see that the load span here is 3H, or 3 times the panel thickness, where the bending strength, it is 6 times the panel thickness for the full scale bending test. So what is the allowable acceptance criteria? The characteristic bending strength of the large finger joint has to be greater than the declared characteristic bending strength of the large finger joint. So this is actually not included in PRG320, but only exists in this European standard. CLT performance criteria for this layup requirement. What is layup? Layup is information about how it's been constructed, how the timber are oriented, and which species are used, and quality of the layers and all that, and which have to be all documented. And according to the standard, it has to have at least 3 layers. And this is something interesting. It says at least 2 solid sawn timber layers should be there. And maximum overall thickness, I'll get back to that, this least 2 solid sawn timber layers. I'll get back to that in a bit. And maximum overall thickness is 500. And total thickness of the wood-based panel layup it's allowed up to 50% of the overall thickness of the CLT. And there are exceptions, which is going to be for the structural composite lumber and plywood. Here, so let's say you were to make this CLT using LVL. According to this standard, like let's say you want to make you want to produce 3-ply CLT under this ISO using LVL, then you actually must have the surface layers made out of solid sawn timber, because it's asking for at least 2 solid sawn timber layers should be there for CLT that's being qualified under this ISO standard. Okay. And another interesting thing is it actually also limits how much of the wood-based panel can be used, but it gives exceptions to this plywood and the structural wood composite lumber, where LVL also applies to. Let's compare with the PRG320. This is a lot of text. You don't have to read everything. And this, I think this presentation will be shared after this webinar. So if you want to look into it, you can go through them. So this is the latest list of basic CLT grades and layups that's specified in this PRG320. It's more standardized. It seems less flexible, but actually, if you read PRG320, it allows you to make CLT with any structural composite lumber, but you just have to do the testing from your end if the product is not included in their standard. Let's move on to CLT performance criteria. This is the code from ISO regarding the mechanical properties of CLT products. This standard provides very, very basic information for the testing. And also, it only covers the basic tests, which is going to be the bending and the shear test. And well, if you read it here, so it says mechanical resistance of CLT products shall be determined by full-scale test or by calculations based on the properties of the layers. But there's no information about what are the calculations are they talking about, right? And it says in this document, mechanical resistance jointly covers the following essential characteristics: MOE, bending, compressive tension, and dose strength. But there's no test standards that it refers to when it comes to compressive tension, shear. Actually, it covers the shear, bonding strength. So I think it can have actually more thorough information, more information about what are the test setups that can be implemented, and so on. So it actually only provides information about this bending stiffness and the bending test and the shear test. And it even refers to this ISO 13910, which actually stands for, which is for strength graded timber, not for this CLT. And well, this is quite standard. So like this PRJ320 and European code, it's asking for the specimen width to be more than 300 millimeters. And here on center span to specimen thickness ratio of greater than 21 for the bending test. And for the shear test, it's asking for the ratio of 5. But at least I was wishing that this it describes what type of testing are they looking for. Well, here they're referring to the 2-point bending, where this is the center point bending for the shear test. So certainly there's room for improvements, I think. Durability, and this is this standard considers three scenarios: bonding performance, 3 scenarios. So solid sawn timber layers without preservative treatment, solid sawn timber layers with preservative treatment, and CLT treated with preservative treatment. So these are the 3 different scenarios they're looking into. Okay, and if they're, so pretty much their philosophy is, if they're made with untreated timber, then the natural durability of that untreated timber should be the durability performance. Okay, so, and if the solid timber was treated and mixed with other ones, I'm going to get to that in a bit, but if they're treated, then it's supposed to have the same is supposed to satisfy the intended service class, like the CLT, and the timber will serve for the same class. And if CLT is, so I'll give you a schematic chart of like what does it mean by this, like 3 different ways. So let's say, what if the CLT is built up of different species or of treated and untreated layers? Okay, and it's in this standard, it says only the natural durability or the preservative treatment of the layer with the lowest durability shall be declared. Okay, so I don't know whether this is a fair statement, because if you have 3 layers and the 2 outer layers are preservative treated and the core layer is not treated, then you have to claim that durability of your product is going to be coming from the untreated one. So not too sure about that. Well, what is this? This is the actually this was the figure was part of my research grant proposal that I submitted when I was in United States, when I was working for Mississippi State University. And so the whole idea, this actually explains what it means by making CLT with untreated timber, which is on the top, and on the middle, it's making CLT with treated laminations. And the bottom one is you actually make the CLT and treat them after, which means you're treating the CLT product. And is this just like some sort of hypothesis or what? Actually, I have done it. So you see that these are the, you cannot really, you can tell the third one here is the preservative treated CLT, but you cannot really tell which one is preservative treated or not. right? So you see that actually this depends on which of these preservative system that you're using. You might not even recognize much in color. So in terms of appearance, they look okay, and you see that this was actually they were at the different retention level, and the one the one that you see on the bottom that was treated with copper azole, well the middle was treated with the micronized copper azole. So that was my previous research. And standard also asks for the documentation of the formaldehyde emission and dimensional stability and appearance classification. So, well, I think our formaldehyde emission and the appearance classification, those ones are quite straightforward. Let's talk a little bit about the dimensional stability. When we they're quite concerned about this dimensional stability, but let's see how they're measuring it. So they measure the reference size, which is the size of the CLT that's measured at the reference moisture content, which is going to be around 12% to, like, let's say 13%. So any moisture content that reached at the condition of 20 Celsius and 65 relative humidity. So that's the reference size. And then there's a corrective size at the actual moisture content. So that's this is the size that has been dimensional after the dimensional change. Okay, so let's say you're looking at you're trying to install this CLT at really humid condition, that obviously the corrective size is going to be somewhat bigger, right? So how do you predict the corrective size? Well, there is something called shrinkage and swelling ratios that's available to be adapted to predict what is going to be the size after being exposed to certain condition for certain duration. So it says allowed difference between the reference and the corrected total depth is going to be 2 millimeters or 2% of the reference depth. Okay, and allowed difference between the reference and the corrected single layer depth is going to be 1 millimeters. Straightforward. And there is a section in the standard that describes how CLT product assessment shall be done. First, he talks about the qualification test. When do you do the qualification test? At the beginning of the production or of a new or modified CLT product, or at the beginning of the new or modified method of production. Okay. What are the characteristics? It says all characteristics included in this document for which manufacturers declares performance. I think that's very, again, I think I wish it can be more specific. And here is CLT performance criteria. It says CLT layups, mechanical resistance, durability, and dimensional stability and appearance. But when I say characteristics, I hope they say they have more information about this mechanical properties. It also requires documentation of the test, and also something called declaration of the performance. So declaration of the performance is a manufacturing specification for CLT products that conformance with the product with the standard requirements. And this DOP is used for factory production control, which I'm going to talk in a bit. So as for this quality assurance, this standards refers to something called this Factory Production Control System, FPC. And this term, you will find that this the same term in European standard, which is it's very, very thorough. So if you have more, if you want to have deeper look into how this FPC is being implemented for the European products, please do so. So this FPC is a written policy and the procedures that ensures that that the produced CLT conform to the declared characteristic performance, and it's an ongoing evaluation of the product properties. And one thing that's I think it's really important to point out is the responsibility of doing this implementing FPC belongs to the manufacturer. They can outsource, they can subcontract this FPC activities to like some third party, but they are not responsible for this FPC management. It has to be the manufacturer. And also the raw materials and the production conditions of the products shall be traceable. And the production and process quality control activities which guarantees production under controlled conditions shall be documented as well. Okay, so it's asking for a lot of documentation. And then this FPC should have this testing and the testing and evaluation, and also how non-compliant products will be handled. So I think I'm running out of time, so I'll try to be quick here. And so for the non-conforming products, there should be a procedure that's clear, which is some sort of action plan how to eliminate the cause of non-conformity in order to prevent it occurs again. Okay, and handling storage and packaging, make sure that they're handled in a way that the damage or deterioration are prevented. And this FPC system actually has two schemes in it. One is going to be the initial inspection of the factory and FPC, and the other one is how to keep it running all the time, so continuous surveillance of FPC. So when do you do the initial inspection of FPC? That's when you finalize the production process for commercial operation, and obviously this the DOP gets also reviewed at the same time. And for the continuous surveillance, I don't think the surveillance is the correct word. I think it's actually straight from the ISO standard, but I think it should be some continuous monitoring of FPC. So pretty much it's asking for the whether the implementation of the FPC test plans are correctly done, and the periodic maintenance and calibration of the product equipment is done, and the review of the test records to make sure that the CLT that's being accredited or they qualified under this ISO standard performs as it's supposed to be. And if any change has been made since the last assessment of the surveillance, then the FPC test plans and the production processes for each production shall be reviewed again. So in summary, CLT manufacturing process has been standardized. You have seen it, and there's several CLT products. CLT product standards have been developed even for smaller markets, and I went over this ISO 16696. It's an internationally acknowledged CLT standard. And it refers to, like when it comes to the specific testing, it refers to the national standards. And comprehensive CLT, it actually has a comprehensive CLT component requirements, but for the CLT performance criteria, it's quite basic. And the information about the product assessment and also quality assurance, those ones are quite general as well. So that's why a lot of the manufacturers, if they don't use this ISO 16696 as their SOAR document, they combine with another standard as well, such as a European standard. So thank you. These are the actually CLT that my students made during my class, and I'll open up for any questions. Emma?
Thanks very much, Thomas. That was very interesting. We've got a few questions here. The first one being, why do the lamella need to be further dried at the CLT factory to 12% moisture content? What would happen if they used the sawn timber at 18% in their manufacturing?
It doesn't glue up. I mean, well, it will glue up, but the variation is going to be more if they use 18%. So yeah, so like they do have like this conditioning, I will say, section in their factory to make sure that it goes below 12%. For example, there was a factory, there was a company that wanted to go for this preservative treated CLT, and especially for the preservative treated timber, when it came out from the kiln dry, it came out at average 19%, which doesn't mean that all the laminations have moisture content that's below a 19%, which actually triggered quite a bit of a bonding problem. So yeah, that's the reason. Yep.
And does that depend on the type of glue that's being used as well? We've had a follow-up question saying, I thought some moisture up to 20% helped PUR glues with bonding, but does it depend on the type of glue?
Well, yeah, like if the glue company, because yeah, if they play with the recipe, this glue recipe, the chemical formulation in it, yes, this the moisture can help, but that's not. I don't think this, like if they're going for up to 20, I am pretty sure it's going to be problematic, based on the research that I have done. It start to have issues after it's hitting like 15% or so. Yep.
What is the period of time that's used for pressing the timber? I think that's meaning how long does it take typically for the timber to be pressed up? And is it different in the different types of presses?
It's really comes to the adhesive that they're using. So you like if any manufacturer gets the adhesive from any adhesive suppliers, they will give them they will supply them with the product specification, which actually has the pressing time in it. So and a lot of the product name goes by how long it takes to cure. So it's like if it's like 30 something, that's like 30 minutes. If it's 60 something, that means it's the curing time is 60. So it really depends on the adhesive, like the time to cure, rather than the press system.
Okay, and would that be, so if it's a specific type of adhesive, then it would be the same time period, whether it's a vacuum press or a hydraulic press?
Yes, definitely.
Thanks. We've got a couple questions about treatment, preservation. Could you comment on the process for preserving or sealing out the risk of moisture and bug ingress? Or is it more efficient and healthy to just have a system to keep the CLT dry rather than preserving it?
Well, I think that's always a big question that's been going on. But well, depends on the market. Let's put it that way. It depends on the market and what is the major regulation that's having on this preservative treatment. But for example, when I was talking to my colleague from Korea, he was like, they cannot even imagine using preservative treated timber for any structures because they're so concerned about the indoor air quality. But here in New Zealand, everything, all those structural products has to be preservative treated. Yes, but is there other way of getting around this preservative treatment? No, I would say if they go approach more from the system level, working with engineers to come, building engineers or building physics experts to come up with a system, they can guarantee it can be tried or it can be prevented from the fungal attack and so on, then I think that might be a better solution than trying to change the policy of some of the countries. And I have done some research on this protecting the CLT panel by putting something called it was a steel mesh that can be put on to. It's like it's a steel mesh with really tiny hole, so the termites cannot get in, type of thing. Those kind of stuff can be like, it can be a solution.
Thank you. Yeah, we've got another question here that's asking the same that you've just answered of why does New Zealand use treated CLT when other countries don't? But I think you've touched on that very well. If we could just keep the CLT dry, then we don't need to be looking at treating it.
Yeah, and I can be quite personal here, even though like how many we have 235 who's listening to this. I got to be careful here. But for this treated CLT, it's not impossible to make, but the moisture content has to be really controlled well. And in terms of bonding and so on, if you control the moisture content and if you use the right preservative system, it is doable. Do I recommend treating the CLT after making the CLT, just putting it into the pressure vessel? I've done it, and I'm not recommending it. It's quite. If the panels are going to be used for outdoor, then it will be okay. But if it's going to be used for the indoor after it's been treated, then it will get some dimensional, like the cracks and all that from the dimensional changes.
We've got a question about what is the process of treatment of CLT, which you touched on a bit, but the follow-up question is there any possible percentage in improvement in mechanical factors? And roughly how much more does it cost to have treated CLT versus non-treated?
Well, I would say in terms of the cost, it's going to be, if you think about manufacturing CLT with untreated and just treated, then the cost to buy the treated lumber or the laminations and the cost of buying untreated, the cost difference is going to be pretty much going to be the cost difference of preservative treated CLT and treated CLT. I mean, treated CLT and untreated CLT. And in terms of mechanical laws and all those kind of stuff, very minor. I can guarantee it's very, very minor. I also have done the testing. I have done this bending test and shear test for preservative treated CLT. It comes out to be, it's a little bit lower, but statistically, it's really difficult to say there is a huge difference or there's a huge reduction due to the preservative treatment. And even from the bonding too. Some people my hypothesis was if I go for higher retention with preservative treatment, I thought the bonding performance was going to go down compared to the light treatment, but there's no significant difference neither. So.
Interesting. Do you think that any more manufacturers are likely to pop up in New Zealand? Any CLT manufacturers? Well, it's a bit of a hard one to answer, but
not me, but I don't know. Like there is a big push from New Zealand government for pushing for the wood processing, but that's a difficult one to answer since that's I'll just put it that way.
Yeah. Fair enough. People are very interested about the preservative treatment topic. Preservative timber certainly needs more research. Is it possible to have untreated CLT approved in buildings in New Zealand? People want less chemicals in buildings. Boron may be acceptable, and how do you see this heading?
I think boron is acceptable. Boron is acceptable, and as far as I know, well, I'm still learning about this durability requirements in New Zealand since I just came here 2.5 years ago from US. But one thing that I can tell is, well, in US, I was actually working, as I said, in Mississippi State University, which is very south tip of US, where termites and this fungal attack is just dominating. Even there, they don't use treated CLT, you know. But here, it's mandate. But in terms of retention level, I think for now it's H1.2, which is the lightest one. So boron is fine. And the one that I have tried back in States was with the highest retention level. So maybe that's why all the CLT after the treatment was almost all cracked up. But if you go for the light treatment or even for the surface coating, but there should be certainly more research that needs to be done, because like a lot of the times people say like, what if you just make sure that the covers are all treated like or coated? You know, that can be a solution. It can be, but it just have to be supported by the scientific evidence. So that's what it is. Yep.
Yeah, and I'll just add to that as well. There have been some untreated CLT buildings that have been built in New Zealand, so it's definitely possible. It's not always that straightforward, but with use of building physicists to do analysis of moisture in the buildings, and it depends as well on where in the country you are and what authority you're going through, but there are definitely paths to get through that, but it's not always straightforward. And yeah, definitely agreement that there needs to be some more research done on that. Another question about fire requirements. I guess this is related to the standards. Are there any fire requirements in the standards for CLT?
Yes, actually, I got quite a bit of information from Professor Andy Buchanan about this fire requirement, but I couldn't include it in today's presentation since it was getting too lengthy. But yes, they are for PRG320 and this European CLT standards, they both have this clause for the fire performance. And according to Professor Buchanan, they're in the middle of updating their fire testing for their CLT. So the designers can actually have the charring rate to be used for when they are actually calculating like how much of the performance is being left after the fire exposure. But so basically for now, yeah, so like this ISO 16696 doesn't have one. It doesn't have one, but the European and also this the PRG320, they both have this fire testing in it. And another thing about ISO 16696, the one that I presented just now, it's not really distinguishing the bonding performance from the adhesive performance. So a lot of the standards, they actually separate them out. So bonding performance belongs to the CLT product. Adhesive performance is, as it is, that's supposed to be done by the adhesive manufacturers. But it doesn't really distinguish these two in this ISO 16696. So that was another thing that can maybe improve in the future, maybe.
Interesting. Yeah. The bond performance of adhesives on preservative-treated timber can vary depending on the type of preservative used. Are you aware of any testing that confirms performance for the adhesive and preservative combinations that are used most commonly in New Zealand?
No, not in New Zealand. And I know in New Zealand, Gary from Auckland University, he looked into different systems than I did. So the system that I looked into, I can tell you, I looked into this MCA, micronized copper azole, which is the preservative system that's gaining popularity around the world. And the glue system that I looked into was melamine formaldehyde and polyurethane and phenol. I mean resorcinol formaldehyde as well. And when I compared the adhesive performance, they're the same. It was like there was no significant difference. But when it comes to polyurethane, it tends to be more ductile. It's more flimsy. So it's a little bit more gummy. It's actually more gummy than the other two. So, but they all performed pretty well. And again, this is when actually at specific manufacturing primers, we retried them to, I think it was 11% or even lower. It was very low. And when the manufacturer, when there was a commercial producer tried the same recipe at high moisture content with average moisture content of 19%, they couldn't glue up. So that's what I can tell you. Yep.
Interesting, thank you. I think we probably have time for one last question. NZS 3602 identifies timber species not requiring treatment to achieve certain durabilities. Could this standard be used in production of untreated CLTs in New Zealand?
Yes, definitely. So for the durability class, durability performance, it actually says, so durability performance of timber is acknowledged as durability performance of CLT, just put it that way. So if they're using durable, naturally durable species, then their CLT is supposed to be naturally durable too. Simple as that, yep.
Yeah. Awesome. Thank you very much. Well, that's perfect timing. That was our last question. We're just at 1 o'clock now. So thank you so much, Thomas. That was a very interesting presentation. And thank you everybody for joining us today.
Okay,
Have a good afternoon.
thank you.